So just to introduce myself, I am Charlotte Loudon, Raytech's Marketing Communications Manager, and I will be hosting today's webinar. My colleague Andrew Maguire, Raytech's Business Development Manager for our security and transport sales, will be running you through the main content of the webinar. And we will also be joined by John Patterson, Raytech's project engineer, for the Q&A session at the end of the webinar. So before we get started, I just want to note that we will answer all questions at the end of the webinar. So please submit them in your questions tab in your GoToWebinar control panel, and we'll come to them at the end of the webinar. So I'll now hand you over to Andrew.
Yep, thank you, Charlotte. Hopefully you can all hear me nice and clearly. So good morning from the UK to everybody watching. Once again, thank you for joining us. So as Charlotte said, once again, my name is Andrew Maguire. I'm a business development manager over here at Raytech. So what qualifies us to talk about mobile security? Raytech's been around for the best part of 20 years now. We specialize in external lighting for CCTV. We also have quite a large amount of business applications within the transport industry, whether this is continuous lighting or pulse lighting. The reality of it is we've managed to watch this technology develop over time, so I'm quite happy to talk to you today about this. The agenda is fairly straightforward. What are the various components of a mobile system? Where are you going to find it? What considerations do you need to have as a user or maybe as a provider, one or the other? And a bit more on how to specify for the individual system. A bit of help on that. Questions and answers at the end. Now, if I don't get to every question and answer, I will obviously email you back at the end. If you happen to think of a question a week from now, we're more than happy to talk about this with you. A lot of the time with this job, I tend to find making sure the information is out there and you have someone to speak to, that's half of the battle. So please feel free to drop me a message or find me on LinkedIn, anything like that. Firstly, what does a mobile system consist of? First and foremost, on every single system, IP cameras. You're talking surveillance, you absolutely, as a requirement, need to have real-time footage. Whether you're watching it all the time or just for recordings afterwards, surveillance is always going to start with some form of internet protocol camera. I'll come on to why the internet protocol, the IP part, is important later on. To help with this, you're also going to need external lighting. Now, there's vast amounts of reasoning as to when you will need this. I'm going to build on that as we go through the presentation. The general idea is all cameras are going to need light at some stage. The more light you have on scene, the better. I'll build on that as we go. You may also find these systems have a speaker or a siren on it of some description. For the most part, all mobile surveillance technology is going to be fairly modular in what you want. Whether you want to just monitor, say like a long road on a fairly narrow angle, if you want to do a 180-degree fence line, or even as far as 360 degrees. You tend to find your mobile systems will be fairly modular in terms of what they can do, or they may have different apparatus for different roles. The idea being, once you have the system, if you needed to move it to somewhere else for a completely different role, you should be able to do that in one go, rather than having to let things come and go as we go. A couple of extra points to have to make to start with. The external power source is one of the main considerations you will always have to make. You tend to find that either going to be a fuel operated generator or solar powered. The majority of mobile applications don't have access to mains power. Sometimes they will, and that's great. You can basically do what you want at that point. But the limitation with generators or solar panel is you can't necessarily have the biggest pieces of technology up. You would have smaller cameras, smaller lighting, smaller powered units. Now, that's not a brilliant limitation. It's not a bad limitation either. What you can get out of modern technology will still cover the majority of applications that you would use a mobile system for. Remote management, that's referring to once you've put the tower up, you tend to want to leave it alone at that point. You want to be able to walk away, and any adjustments you would need to make, you would want to make remotely. I'll build on that as we go through. I'll keep on moving through. Why use it? Typically speaking, it's going to be temporary site surveillance. Anywhere you're expecting a lot of changes, or more importantly, maybe where there's no external power sources already available. I'm going to run us through a few examples physically in a minute of what that may be. but I just want to make sure we're all fairly aware. The idea of these is they're not necessarily permanent solutions where that can be avoided. Reason being, the generator will need more fuel, the solar panels will need to have some kind of cleaning rotor, that kind of thing. But anywhere you're expecting a non-permanent setup to be needed. Now, whether that's sort of on a, for example, a construction site is quite a common one. You have a lot of equipment coming and going, a lot of very expensive machinery, things like that. And the construction site will be moving every single day, most likely. So you would want some kind of tower that can keep an eye on that kind of thing. Has a bit of a dual purpose when it comes to construction. It's not just defending against criminals in this case. You could also use it for more general application. AI these days is getting very, very smart. I've seen applications where you're using a mobile security tower to monitor if people are wearing hard hats on site, or if there's any unexpected behaviors, things like that. The importance of the construction one, though, is very much you need to be able to move it to maybe defend weaknesses and fences that aren't always going to be there. And then once the construction is completed, you would typically move on to a more permanent solution. Agriculture is a really good one. Anybody who's recently watched Clarkson's Farm on Amazon Prime, there are other networks available, will have been made aware of just how expensive farming equipment is, whether it's for the tractors, the seed, or even just for land, that kind of thing. What you tend to find with agriculture projects is you're not going to try and defend the entire perimeter. So let's say you've got a 5-mile perimeter. What you would defend is the access points, the gates, the roads, anywhere leading to where your equipment is. Or even more temporary solutions such as I've just made this field into a pig farm. We're now going to put some temporary measures down until we can get something more in place. Wind farms, another very good example. We've seen a lot of this over in Europe. The UK ones have a fair amount. What you're looking at here is very expansive lands, where there's a lot of ground to cover and probably no existing infrastructure. Mobile surveillance systems. You'd mount to defend the key components when you're building, and then over time, you would probably expand on to have a more permanent solution. But as far as controlling access points, keeping an eye on areas that you don't necessarily want to send people into, that's very much where mobile surveillance has got a very big presence. Event safety. Now, I live very close to Newcastle in the UK, where there's often random surges of crowds based on a different event that's happening. So what you're starting to see largely in the streets is a mobile surveillance tower, which is capable of counting, for example, how much personal flow is going through. It might monitor their faces. It might look out for unexpected behaviors. It might just be there for recording purposes later on, potentially for a prosecution later on. So mobile surveillance, for all I said, it's smaller cameras, it's smaller lights due to the power constrictions. The reality of it is you can still do whatever you want to do with a permanent solution, but in a mobile format. You'll just need to possibly use slightly more than you would normally use. Key considerations: has to be cost effective. The benefit to smaller cameras, smaller luminaires, smaller power systems is you're not going to have a £2,000 camera at the top of the system. You're going to have a more compact design. Again, temporary. Fast, hassle-free deployment. So what we're talking about here is the majority of systems these days will be on some kind of, you receive a package, you would hoist the tower to whatever height, usually via a pulley or some kind of counterweight system. You turn the generator on, and then it would connect to a network, and then it would be monitored by a third party. The general obviously the point here being you need to have these things monitored. It's all very good and well surveying an area, but you're looking to create alerts, have a good response time to anything that you need to change, whether that's criminal behavior or unsafe practices on a building site, for example. The majority of the bigger companies that already exist that do this will have this as part of their package. It's always worth talking to them about exactly how they want to operate this sort of system. But between the modularity of the systems, the third-party monitoring, in the modern era, this is usually quite a straightforward process. As for providers, what do you need to consider before giving these out to loanees, as it were? It needs to be dynamic. It has to be adaptable. You need to have a system that can adapt to multiple different scenarios. So for example, if someone rented a tower from you and they were defending a perimeter that was a very wide shot with quite a lot of distance, and then they wanted to instead defend a road point, you would want the system to be somehow adjustable without too much fuss to make sure it's going to be adaptable to whatever consideration they may need it for. Further to that, you want a similar solution to defending a street as to defending a rural area. It would have to be quite a rugged, robust unit, very self-reliant. You need to know exactly what it's going to do. Device integration is more or less expected these days. Your internet protocol cameras will talk to various things, such as external lighting, sirens, things like that. There's even been applications where we've seen kind of laser grid scanners. So if someone crosses the laser, they would get pinged, the siren would go off, that kind of thing. We're a long way past these days just sort of dumb units that passively monitor. A lot of it now is about creating alerts, making sure whatever behavior you don't like gets stopped as quickly as possible. The ability to control remotely, I've already touched on this. The general idea is once the tower's up, you shouldn't have to make any modifications to it. If you decided, well, actually, I need it slightly more zoomed in, or I need my lighting to do this, I need a different response from the sirens, you should be able to do that from, say, a network computer, something like that. What's the importance of using external lighting? So as it says on the screen, we're always going to provide the best results, and the most important system here is we're going to give you increased distances for larger sites. The majority of people are now aware of integrated infrared technology in cameras, the idea being that cameras don't struggle during the daytime because we get their light from the sun, but at nighttime we were finding, particularly over in the 90s, cameras fell off at night and they couldn't see anything. They were just a bit useless. So external lighting's always existed, but as part of the adaptation from cameras, they started putting integrated lighting in. Now the issue is, integrated lighting tends to be quite a narrow beam and it struggles at both distance and width. I have an example imagery coming up slightly later on which will go on to that, but what I need to draw your attention to really is to get the optimum image, you must have the correct amount of light downrange. Murphy's law, which is the law that what can go wrong will go wrong. If you have a 5-meter gap of slightly blurry, slightly grainy imagery, that's exactly where the problem will occur. This can be easily avoided by external lighting and making sure you have a good, clear picture of what's happening. Has further benefits if your AI is able to see what it's doing, that kind of thing. The other half of it is, if each tower, instead of seeing, say, 20 meters at night, can suddenly see 100, 200 meters at night, you need less towers, less expense, more cost saved. Keep it moving on. Types of light, realistically, there's two. There are other variants available, but as far as what I believe is truly important for the majority, you've got infrared. Reason being, cameras are very receptive to infrared. It's invisible to us, but cameras, particularly at 850 nanometers, can see it in incredible detail. The general idea, obviously, is invisible. No one can tell they're being monitored, so they wouldn't create different behaviors as a result. I would like to note that all infrared panels will have a slight red glow to them. The actual infrared itself will be invisible, you can't see it, but the panel itself have a small red glow. This is largely unavoidable. Even 940 nanometers, which is considered a more covert panel, it's about 50% as efficient as 850, will still have that. You would make the argument that if somebody knew what that was, they would probably be deterred by it a little bit. If someone didn't know what that was and there was a random red glow 200 meters away, they wouldn't really think much of it. Zero light pollution. This is kind of key for your residential areas or anywhere you might impact general life, whether that's human life or wildlife kind of thing. Following that, no visible light to assist or alert intruders. So this is quite useful. You would be able to see exactly what they're doing, and whatever your response would be, whether it was sending security, having a look for yourself, calling the police, You will be slowing down the criminal behavior or the unwanted behavior, but not affecting your own. You will still be able to guide in directly to where you're going. So by comparison, white light, often used in conjunction with IR. To give you an example of where white light and infrared differ in terms of distance, if you had a 200-meter capable white light panel, you would probably get 500 meters in infrared, just because of how receptive cameras are to infrared as much as anything else. So for mobile security, I tend to suggest, where possible, use infrared. Just because it gives you that distance, it gives you the ability to have less towers, and generally speaking, more covert, it's more what you expect to find in this kind of thing. But white light does have the benefit of being a very good deterrent. Now, working in the external lighting industry, I have been daft enough to experience this for myself. 3 in the morning, pitch black, walking through. I've triggered a white light on, and let me tell you, it was horrendous. I scarpered pretty quickly despite knowing what was happening. When I say use in conjunction, what you would tend to find is you would have your infrared is generally monitoring what's happening. And then say a camera detects movement, you could then switch it to white light, and then you would put white light downrange. It's going to help you identify the intruder in terms of color imagery. You get what they're wearing, what their clothes are, skin color, hats, what tools they have, things along those lines. So between the invisible nature of infrared and the white light deterrent, there's a balance to be had. You want the distance of the infrared, but sometimes you want the go away of the white light, for lack of a better description. Configurability. External lighting is usually remote controlled these days. You'll have dumb units and smart units, but the majority of it is controlling how the unit works on site. Now, if I was to give you a generic light and say this will work up to 100 meters, for example, but it goes on site and it only has to do 20 meters, having the ability to control the power, so reducing how much power it's putting out, would be useful. Your employees would not thank you to have a 200-meter light shining at them from 5 meters away. Being able to control the different power settings, how wide the FOV is or the field of view is, things like that, it's all very important. The bottom wording, photocell sensitivity, that is referring to a unit would detect how dark it gets, and then at a certain darkness, it would turn on. You're going to find all over the world, there's different levels of darkness during night times, so being able to adjust this is very useful. If you had a project that was slightly longer term, for example, say 6 months, 12 months, something like that, being able to change this without having to physically touch the unit is a very big benefit. Other ways of doing this, integrated web interfaces, API integrations. This is talking about VMS software, video management systems. The idea being you would tie in your cameras, your lighting, your sirens and your speakers all into one system to be controlled. And that would mean rather than only controlling one camera, one site at a time, you could have one person very easily controlling multiple sites with some assistance. Now, I've seen some very interesting VMS softwares recently. I had one chap who was monitoring 50 plus sites, and he could literally type in the word red shirt into his VMS software, and it would show you all the current red shirts, all the historical red shirts that had been through whichever sites he has selected. So within terms of where AI has gone, you've really got a lot of power at your fingertips. We're almost getting to that point where it's your creativity is the limitation rather than the actual physical capability of the LED lighting, for example. A few of the major players here that are others available to give you examples of this. It would be worth, if you're new to this, having a vague look at what these guys in particular do. They've been leading the charge for quite a while now. Hardware integration, as I say, it's multiple different systems. On this particular picture, this is going to be a 180-degree defense of some kind. These cameras appear to be able to pivot, and what we have here is external lighting to make sure that wherever these cameras pivot to, they have sufficient lighting. To give you an example, Raytech, there are others available, will have a single panel that can do 500 meters of infrared light. Now, this is a big beastie panel. It wouldn't be much use for mobile, but the important part is it can do 500 meters at 10 by 10 degrees. But if you wanted to monitor rather 10 degrees, you wanted to monitor 120, this comes down to about 70 meters rather than 500. So when you have your integrated infrared, you may have 2 little unfocused LEDs, maybe 8 sometimes. They're not going to be able to handle very much distance. I'll have a little example coming up, a little video of the difference between 10 and 60. What I want to drive across to you really is the external lighting just takes away that ability for something to go wrong based on an unknown environment coming up, something like that. Network capability, dynamic surveillance, it's very much part of the package. It should be configurable, it should be adaptable, it's all fairly straightforward. Automated lighting responses, this is usually more of a white light thing. It's basically if the camera detects movement or if it detects something it doesn't like, you'd be able to make the white lights flash, something like that. Sirens go off, alarms go off, things like that. So I referenced this earlier. This background shot is a camera analytic AI tracking trucks and people. With the people, is tracking whether or not they're wearing a hard hat or not. So often deployed mobile, I would say the majority of mobile these days will have some kind of AI coming with it. It isn't strictly necessary, but it just makes life a lot easier if you can have it. We've all seen the classic examples of one chap trying to monitor 70 screens at once or something daft in the control room. AI will be able to monitor all the sites you have, all the cameras you have, however many hundreds or thousands, and then trigger alerts based on whatever you set it up to do. So for example, in this image in the background, the camera detects for someone without a hard hat, there's some kind of alarm on the system, tells a foreman, go and have a word with this chap, tell him to put a hard hat on, that kind of thing. It's hard to imagine it in terms of multiple sites because I have an image of one, but you think one site may have 30 cameras on, you may have 7 sites, 210 cameras, that kind of thing. It's much easier to do it with some kind of AI assistance these days. I'm using the word assistance because for the most part, you tend to want to make sure you have a bit of tolerance, you have somebody checking what the AI says is correct. On that note of correctness, the clear imagery is the key point. If you have not enough light downrange, the camera is a bit blurry, it's not the camera, the picture is a bit blurry, a bit grainy, it would confuse the AI a little bit. I've got a little picture coming up, but no light basically means you have no analytics. So if you, for example, here, the left-hand side is a low light camera with no additional lighting, the right-hand side is external, lighting assisted. The left-hand side, you would be forgiven in reality for thinking this picture is good enough. And this is one of the things we have to watch out for, particularly when specifying lighting, is a lot of the time customers will think they have a good enough light. But in reality, you compare the two images. Yes, you can see the car on both. You can kind of see the equipment behind it, but that entire back pathway is completely gone on the left-hand side image. What these red boxes are showing is essentially the AI is saying, I don't have enough light to have a high degree of confidence what's happening here. I'd say that's about 50% of that image is no good. You might get false alarms as a result of this. You might have to waste someone's time to go and check. It turns out it was just a leaf and the AI panicked, something like that. You need to have good lighting on scene in order to reduce false alarms, to understand what's happening, and just benefit the analytics. Various ways you can think about this. Now, this is from my own company, an interchangeable lens system. Some other companies do it on kind of like a banner where you would rotate a dial and the lens would change. The idea of external lighting is whatever the camera can see, you would match your luminaire to the same FOV, field of view. So if the camera sees, say, 60 degrees, you would have a lens in that's 60 degrees. We'll go on to why that's important in just a minute. It's ideal for mobile sites. The idea of this one is quite straightforward. You pull it out the bottom, you put the new one in, 2 screws, good to go, while maintaining your IP ratings. IP66 is very common. Sometimes you see IP67. It's all part of what the customer will want. It's about adding that flexibility. You would probably want a fairly generic light unit, low cost, lightweight, low power draw that can cover the majority of whatever applications you're interested in. Remote controls, this is largely about the configurability without having to directly access the tower itself. If the luminaire or the camera is up 6 meters, 13 meters, you don't really want to get a ladder up. You don't want to have somebody with access control have to be called out. It's much easier if you can configure it afterwards or at the time and then walk away from it. And should you decide you've changed your mind, quick button press, good to go. Other considerations, because they're remote locations, as I've mentioned, you need to keep an eye on your power consumption. Because we're using the smaller cameras will struggle more at night than your big beastie ones would. Now, your external lighting will benefit a small camera as much as it will a big camera, if not more. Low voltage being a necessity, you can't, as I say, I'm repeating myself at this point, but it's very important. The last thing I would want to do is have someone hoist a tower up and find out they can't power it at all. If you can't power it, you don't get the images, you're not doing the job. Solar panels in Europe, we have a lot of applications for that. Australia, England can do it. We struggle a bit more in November, December, so you're probably more generator focused around that time frame. But the reality of it is, there is a solution for the majority of things these days. You can sort of see the scope of the field that this section is looking at. You would probably be defending up to the fence line in this case, once again, 180-degree application. Hotspot reduction technology is talking about, I mentioned, integrated infrared tends to be quite narrow and a bit limited. The left-hand side is showing this. So the LEDs on an integrated camera won't be particularly focused in any one direction. You're going to be losing a lot of the efficiency. And in this case, on the left-hand side, you can see the start of the image is very well lit, to be fair, but you're not getting complete coverage. You're not getting a good diffuse light going out over the entire sector you're trying to cover. You've lost what's happening in the trees. You're having an unclear image. It's going to cause confusion with AI. It's not as good as it can be with a very simple solution. The right-hand side happens to show one of our pieces of kit. The idea being we're using a purpose-built external light that's at the correct settings, correct power, with the correct lens in to guarantee no matter where the person or whatever you're trying to watch is in shot, you'll get a good light on that scene. No overexposure, no wasted light. The LEDs on your integrated will be trying to light up generally around the camera. Your external lighting will be focused on the specific area you're trying to cover. We're not wasting light into the sky, for example. We're not wasting light directly below where the camera can't see anything. We're looking, where can the camera see? We're going to set up that way, whether it's changeable lenses, where you've got it mounted, things along those lines. Small video here for you. Quick side-by-side comparison. I'll chuck a pause in there. Left-hand side is the additional lighting. Right-hand side is an integrated camera on its own. Now, to be fair, this is 10 meters away. The picture's quite good. If you zoomed it in, you would find, fair enough, you'll get a decent identification out of that. This is 10 meters. But you throw that out to say 60 meters, it's a whole different ballgame. That image on the right-hand side is helping nobody. Image on the left-hand side, much clearer, just as a quick example of the kind of differences you may see. So in summary, towers, flexible, easy to deploy, very modular. It will depend largely on what you're up to. You're always welcome to come and ask me for some advice. We do lots of training, lots of things on our website that might help with this kind of thing. Dedicated lighting is still a critical component, and it's going to be for the foreseeable future. LED technology has moved on quite well in the past 10 years, but we're still at least 10 years away from even having to consider moving away from it, in my opinion. We're at the pinnacle of where the performance is now. What you're going to find is with integrated IR, if there's a problem with the infrared on it, you've lost the camera and you've lost the light at the same time. You're better off having a camera and an external light, because that means if something does go wrong with the light in the unlikely event, you don't lose an entire surveillance piece of equipment. You've lost a component of it, which can usually be replaced very, very quickly. Network capability has to be done. We're kind of past, well, it's harsh. CCCTV, closed circuit television sort of thing isn't really what you're looking at with mobile security. It's all about sending that connection somewhere else. You may find you need an antenna, depending on how remote the location is. This is all things that these companies will have thought of by now. They'll probably have some kind of solution you can ask them about. Any questions at this time, please?
Thanks, Andrew, for that. I hope that was useful to everybody who's online. So I'd just like to invite our colleague John Patterson to the webinar whilst I pull up some questions if we have any. So just to note, we will be providing you with the webinar slides after the webinar, as well as the recording will be on our website, and we will also send you the link to that. So yes, and also if you do require a CPD certificate, please can you get in contact with us, and we will provide you with that. So once we've emailed you the slides, if you can respond to that email, that will be brilliant, and we'll provide you with that certificate. So we do have one question here. Does Raytech have explosion-proof IR lighting for CCTV?
We
Yes.
do. Oh, sorry, John. Go ahead, John.
I think we both answered that one.
Yes, we do. We'll contact you afterwards. We'll show you what we have. It wouldn't be necessarily for mobile surveillance, but we have got the more permanent hardware we could show you.
Brilliant. We've got another one here. What are the maximum distances for Raytech's IR products?
So it's going to depend slightly on what your power limitations are and what you're trying to do. I would tend to suggest it's going to be somewhere between 100 and 200 meters. Now you're comparing that particularly to the integrated IRs of about 50 meters. So you'd probably have, less towers as a result. It will depend largely on what you need it to do, what distances, what angles. Feel free to give us a shout out and we'll obviously help you specify lighting as we go.
Just to add to that one, at Raytech, we specify our distances based on a known on-scene power level. So we will say for infrared that you will get a minimum of 0.3 megawatts per centimeter squared on scene, our quoted distances. So your camera may need not as much light for that, but we can qualify our distances by actually putting a measure onto that. For our white light products, we will say that our quoted distances, you will get a minimum of 3 lux on scene as well.
Brilliant. Just hold off for a few more minutes just to see if there's any more questions that come through. Just if there's not. So we've got one here. Do you sell packs of camera mobile with solar panels or with public lighting?
So Raytech themselves are entirely just the lighting component of a tower, so we will be sold as part of. We could probably direct you to some of the companies that do have a complete package for you if you would like. I'm quite happy to send you an email about that.
Perfect, thanks, Andrew. So just to clarify, there's another question. So when would we use IR and when would we use white light?
So that's a fair question. For the most part, if you need the distance, you're looking at very long distances, say over fields, you would probably want to go for infrared to give you more distance. White light, because it's about half the distance in total distance, for example, 500 meters infrared versus 200 meters white light, you would probably look at what's your power limitations, what can I get out of this, and what would be the best application for that one. They're both going to work perfectly well in terms of giving you good pictures, clear imagery for persecution if you needed things like that. It's more about what you needed at the time. The white light, the benefit is the deterrent and the color pictures. The infrared is you just have much more range. Depends exactly what you need. I'm happy to talk more about that if you like as well.
There's also the environmental considerations now. There's a lot of focus around the world for dark skies and the impact lighting has on animals and human behaviour. With infrared, you do not have any of these issues. So it's all wildlife friendly by the nature of it. And also just from the human point of view, if you have a site that's in a sort of residential area, you don't necessarily want sort of white lights disturbing neighbours and sort of upsetting them. So infrared does get around a lot of the sort of problems that we're seeing with ecology at the moment.
Brilliant, thanks, John. So we've got another question here saying, is it important to know the ambient lighting on site to determine the best IR settings?
Yes and no. The reality of it is with most cameras, you'll get a decent picture. If you're able to adjust these things, do so. But the reality of it is a lot of the time cameras will automatically focus really. So once you've put your additional lighting down, it'll allow for that. As far as, what's the ambient light before you've got there sort of thing, the reality of it is the external lighting's distances are rated from kind of pitch black. So any more ambient lighting is only going to benefit you. It's not going to harm anything, I think would be the important part.
Brilliant. So that's all the questions for now. So I just want to say a huge thank you to everyone who's joined us today. And I would like to hope that it's been useful to you all. So we'll hold on for a few more minutes just to see if there's any more questions that come in. And then from then we'll say goodbye. But thank you. Oh, we do have another question in here. So do you have adaptive IR as per the camera's zoom ratio and integration of the same?
So our smart units, which is what we'd refer to as IPPoE, there's others available out there, you would basically control it via what's called triggers on the software. So when the camera does a certain behavior, you would adjust maybe how much power is coming out of the luminaire, things like that. For the most part, you would just illuminate the entire scene for what the camera would generally be doing, and you would have enough light on the zoom as a result. When you're specifying it, you might want to even say, generally speaking, we look at 35 degrees, but we would like to make sure we have the option to zoom in if we want to. You'll have enough light on scene, but if you want a bit more, it doesn't hurt. But the reality of it is it's all part of the designed package, really.
Brilliant, thank you. We just had another one come in here. So do you think effective use IR for catching number plate vehicles? So effectively, can we use IR to capture number plate vehicles?
Yep, definitely. I'd recommend that, particularly above white light where you can. It's quite, I could give you a very long answer to this. I will try and keep it a bit short. Capturing number plates, infrared. Most plates are retro-reflective in the UK. It changes on country to country. You have like a black writing, white plate, something like that. Very good. The only wet place you might struggle if you have red writing, but we should chat about that separately. The majority of the time, capturing plates, infrared is the way to go. White light can also work. Infrared's probably better.
Have you got anything to add to that, John?
Yeah, I mean, as Andrew said, there is certain number plates which is sort of red and a white background that infrared does struggle with. The big issue with using anything other than infrared is blinding the driver. So the last thing you want is sort of get a nice colour image, but you're blinding the driver at the same time. So infrared is in 99% of the cases what is needed.
Perfect, thank you. I think that might be all the questions. If we have missed any questions, we'll get back to you after the webinar. Yeah, just in case I have missed any. But if I haven't, I don't think I have, then that's it from us today. So again, a huge thank you to everyone who's been on the webinar. If you do require a CPD certificate, we can provide you with this. So if you can get in contact with us after the webinar, that would be brilliant, and we can give you that.